PTL Pro represents the AI in Agriculture podcast where technology shapes the future of farming.
All right, so get this right. We're talking about farming in a region where water is like gold, right? Every drop matters.
Absolutely.
And you're totally at the mercy of the weather.
Yep.
But the weather reports you're getting are about as reliable as, like, I don't know, a fortune cookie.
Right.
That's what a lot of farmers are dealing with, and it's a huge problem that researchers are trying to solve. You really tapped into something with this deep dive request.
Absolutely. And what's really interesting is that we're seeing a real shift from these like broad general weather predictions to something way more tailored, way more precise.
Okay.
It's like instead of just having some weatherman in a far-off studio, you've got your own personal AI meteorologist right there in the field.
Now that's an image. But before we unleash the AI weather wizards, we got to understand why the old ways aren't cutting it. This paper we're looking at focuses on a region in Morocco dealing with serious water issues.
Right.
And they make it clear that traditional numerical weather prediction, or NWP, is falling short.
Yeah.
And it's not just that it's a mouthful to say, though it is.
It is. Yeah, it's not that NWP is totally useless, right?
Right.
It's powerful for large-scale forecasting, like seeing the big picture. But for something like precision agriculture, where a farmer needs to decide if they need to irrigate a specific field based on how much sun there will be tomorrow.
Right.
It's just not detailed enough. It's like using a satellite image to try and spot a single ladybug.
Okay, so the old ways are too broad.
Exactly.
This is where the paper takes us on a fascinating tour through all these data-driven models.
It's like a mixtape of forecasting techniques.
Right.
So they start with the classic statistical models.
Okay.
Things like Autorima and Fast Fourier Transform FFT for short. These models are the foundation, right?
Yeah.
They're great for capturing long-term trends, seasonality, that sort of thing. But they struggle when it comes to those really complex, interconnected factors that we see in weather.
Okay.
It's like trying to write a symphony using only two notes.
Mm-hmm.
You're pretty limited in what you can express.
So we need to bring in more instruments, so to speak.
Exactly.
And that's where the researchers bring in the machine learning models, things like linear regression, and this other one called CatBoost.
Yes. And CatBoost, which uses gradient boosting, and we can get into that more later if you'd like, is particularly good at sifting through data that's messy and complicated, which is perfect for weather data.
Because it's all interconnected.
Exactly. You've got all these different factors influencing each other.
Okay, so we've got the classics laying the groundwork, then machine learning comes in with some more sophisticated moves.
Right.
But it sounds like there's another level to this.
Oh, absolutely. Get ready for the big leagues.
Okay.
Deep learning models. The researchers pitted a Temporal Convolutional Neural Network, TCNN, and the mighty transformer against each other.
Wow. Okay, I'll admit, even I had to do a little homework before this deep dive to get my head around deep learning models.
Right.
It sounds pretty intense.
Yeah, it can be a lot.
So what's the deal with these heavy hitters, and why are they so good at, like, deciphering weather data?
Okay, so we talked about statistical models being like the basics, right? Like a simple dance routine.
And then machine learning comes in with the fancy footwork.
Yeah, adding in some more complex steps.
Deep learning is like setting the dancers free to just improvise, make something totally new.
Oh, okay.
These models, especially
TCNN, right.
they're built to spot patterns that other models might miss completely. TCNN specifically, it's great at dealing with data that changes over time, which is perfect for weather, right?
Because today's weather impacts tomorrow's forecast.
Exactly. So it's not just looking at individual data points, it's seeing the whole interconnected flow, how it all influences each other.
Okay, that makes sense. And the transformer, you mentioned that one too.
Oh, right. That one's like the superstar of deep learning.
Superstar, okay.
Crazy powerful, but it can be a resource hog. It needs a lot of computing power. Okay, so we've got our contenders. Time for the face-off. Which one came out on top when they tested them with the Moroccan weather data?
Drum roll, please. TCNN. By a landslide, especially for predicting things like solar radiation, which is tricky. And what's really interesting is how it's stacked up against the current gold standard, the GFS.
GFS, remind me what that stands for again.
Global Forecast System. Think of it as like the heavyweight champ of weather forecasting. The one they use for those big general predictions you see on the news.
Right. The ones that tell me there's a chance of rain, but not if I need to water my plants.
Exactly. So the researchers, they compared the predictions from TCNN against actual weather station data.
The real deal.
Yep. And get this, TCNN consistently provided forecasts that were much closer to what those weather stations were recording, especially over a 3-day prediction window.
Wow, that's impressive.
Right. Especially when you think about all the resources that go into maintaining something like the GFS.
Okay, so now I'm starting to see why you were so excited about this research. This isn't just some, tweaking algorithms in a lab.
Right.
This is about actually changing the game for farmers.
Absolutely. Imagine a future where farmers, especially in places like Morocco, where accurate forecasts are crucial, they have access to these hyperlocal predictions specific to their fields, generated maybe even by a device on their farm, thanks to edge computing.
Edge computing, we touched on that earlier, but for those of us who aren't fluent in tech, what does that even mean, and why is it such a game changer?
Sure. So normally, these complex calculations, they're done in these massive data centers miles away from the actual farms. Edge computing brings the processing power closer to where the data is being collected, right there on the farm.
Ah, so instead of sending data back and forth across the internet, it's like having a mini weather forecasting supercomputer right there in the barn.
Exactly.
Yeah.
And it's way more efficient that way.
That's really cool. But back to the models for a sec. You said TCNN really stood out when it came to predicting things like solar radiation. Why was that?
Good question. So remember how we talked about air temperature being somewhat stable, relatively predictable?
Right.
Solar radiation, on the other hand, it's affected by tons of things, like cloud cover, humidity.
Right, which can change really quickly.
Exactly. In TCNN, it can see those tiny changes over time, connect the dots in a way other models can't.
So it's like predicting if someone will turn on a lamp is one thing.
Right.
But predicting exactly when a cloud will cover the sun for a few minutes, that's way harder.
Exactly. And that's what makes TCNN so powerful for this.
This is fascinating, but it does make me wonder, with all this AI, all this data crunching, how affordable is this really? Can this actually be accessible to all farmers, especially those who might be struggling? So are we talking about like a future where any farmer anywhere could have access to these like super advanced weather tools?
Absolutely. And it's not just about, increasing yields or saving water.
Mm-hmm.
No, those are both huge, obviously.
Huge.
But think about things like extreme weather events, which are, sadly, becoming more and more common.
Yeah, the paper actually talked about how these hyperlocal forecasts could be used for early warning systems, right?
Exactly. So instead of a farmer finding out about a flash flood when it's already too late, they could have a heads up days in advance.
That's huge.
Right. Imagine getting an alert on your phone that says, hey, there's a high chance of heavy rain in your area in 2 days. You might want to move your livestock to higher ground. Things like that.
Oh, wow. So we're talking about not just protecting crops, but potentially saving lives.
Exactly. And that's what I think is so cool about this research.
Yeah.
It's not just about, the tech itself, but about how it can be used to actually help people,
Totally.
We often think of AI and all that as kind of cold and impersonal, but this really shows how it can be used to solve real-world problems.
Absolutely. It really humanizes it, right?
Yeah.
It reminds you that even in these really technical research papers, there's a human impact at the heart of it. We started this whole deep dive wanting to figure out how to make weather forecasts more useful for the people who need them most.
Right. The people who depend on it.
And I think we've uncovered some really amazing possibilities, from all the nitty-gritty details about different models to the potential to completely change how we think about agriculture.
That's a really exciting time to be following this field, that's for sure.
It really is. This deep dive has been a wild ride. We've geeked out over algorithms, talked about the pros and cons of different models.
It's gone deep.
We really have. And we even imagined a future where AI is helping farmers deal with climate change. If there's one thing I'm taking away from this, it's that the future of agriculture, it's definitely data-driven. And you know what? It's looking pretty hopeful.
It really is. And who knows what other breakthroughs are just around the corner.
Exactly. That's what's so great about these deep dives. We're just scratching the surface here, but the most important part is what happens next, right? What will you do with this information? What questions did this spark for you? Maybe you'll be sending us the next research paper to unpack. Until then, keep those minds curious, keep exploring, and we'll catch you next time.